Okay, 10-7. Let's look at 22. A baseball player hits a fly ball. I don't have a clue what a fly ball is. I watch cricket. Okay, but nevertheless, a ball is hit that has an initial velocity for which the horizontal component is 30 meters per second and the vertical component is 40 meters per second. What is the speed of the ball at the highest point of its flight? Please try this. Please try this on your own. Okay. And then we can look at it. Please try it. Okay, let's get some space here. Okay, so what are they saying? Horizontal is 30 and vertical is 40. So remember, if this ball is hit with a velocity, so it's hit with an initial velocity in a certain direction, okay? And there's your x-axis, there's your y-axis. And they say that the Vx is 30 meters per second and the Vy is 40 meters per second. Okay? So remember, whenever there's a projectile motion, the idea behind projectile motion, to solve these problems, remember you can break it up into x information and y information, and you can solve these guys separately. Okay? I'm not going to go over all those equations again, but you need to understand that you need to break it up into x and y, and you need to understand what's happening in the x direction, what's happening in the y direction. You need to make sure you understand that. For example, in the y direction, we can treat this projectile. Remember, this projectile is going to move something like that, right? We can treat this projectile in the vertical direction, the y direction, as simply a ball that gets thrown up and it comes down, right? That's exactly what's happening. If you stand with a tennis ball, you throw it up and it comes down. That's exactly what's happening to this projectile motion in the vertical direction. So that means we've got all those equations. Vy equals da-da-da-da, and y final equals y initial, da-da-da-da-da, those equations, right? Minus half gt squared. You must go check out all those equations of motion, okay? And then what's happening in the x direction? The x direction there's a very important thing, is that in the x direction, the acceleration in x is 0. There's no, okay, the assumption is that there's no friction, there's no air resistance. But in the vertical direction, you do have acceleration, and it's minus g. If you take up as positive, then it's minus g as our acceleration, ay. Ax is 0. So the horizontal component of velocity, Vx, is always constant, right? Vx final is Vx initial. Okay, so make sure you understand those things. All right, so the question is, what's happening here at the top point? What is the velocity? And it specifically says velocity. It doesn't say horizontal or vertical. It says velocity. So we need to take into account both of these guys. So what's happening at this top point? Well, let's break it up into vertical and horizontal. What's happening here at in the vertical direction? Well, we know right at the top, our Vy equals 0 right at the top. So that vertical component, Vy, is 0. There is no velocity component in the vertical direction because it is 0. Right at the top of this motion, the velocity is 0. Then it switches and it begins to come down again, and the velocity increases. And what's happening in the horizontal direction? What's happening in the horizontal direction? It's constant. So whatever it was at the beginning, which was 30, it's going to be at any point along this projectile until it hits the ground. This Vx is constant. So my Vx there is 30, but because there's no vertical component, v, the resultant velocity is vx, which is 30 meters per second in that direction, because there's no vy. Does that make sense? Does that make sense? I hope so. Okay, so what's the speed of the ball at the highest point in its flight? That's it. That's the speed. By the way, the speed, all it's saying is what's the magnitude of the velocity. There's no direction information there, right? But we know, if we were to say what is the direction, we know what the direction would be. It's horizontal. Okay. All right. Does the maximum height, let's look at 24, does the maximum height achieved by a projectile depend on both the x and y components of its launch velocity? Does the horizontal range depend on both components? Right, so they're asking two questions here. Height, again, please try it, read the information, read the chapters, learn to learn, okay? So there's question 1 there. What are we talking about? Maximum height depend on both the x and y components of its velocity, initial velocity. Okay, so remember, there's its initial velocity v. It's got a vy and a vx component. So does the height depend on both its x and y components? And does the horizontal range, right, the range before it lands on some object, that's its range, right? That's the range from there to there. That's your. So the height only depends on your initial velocity, okay? But the horizontal range depends on both components. So you can see if this angle theta is 0, then there's your v. There's no vertical component of velocity, only a horizontal component. Then what's going to happen is it never rises up off the ground, and it'll just go into the ground, okay? So, but if you raise this up and you increase this angle, then you have this vertical component, which then will allow for this kind of projectile motion. If you keep increasing that angle for a given fixed velocity, you can see that both of them play a role in the horizontal range. Okay? Go study those equations. Go study the equations that describe it. And you'll see that both of these, so it's kind of an optimization exercise. For a given velocity, a fixed velocity, what would the optimal angle be so that I get the maximum range? Okay. All right.